At the end of our last section, we already learned that it takes longer to climb a mountain than to ski down it, which means that T1 is normally longer than T2. Just to give you an idea, T1 is about 2 to 10 times as long as T2. Or in absolute terms, in biological tissues, T1 is about 300 to 2000 milliseconds, and T2 is about 30 to 150 milliseconds. It is difficult to pinpoint the end of the longitudinal and transversal relaxation exactly. Thus, T1 and T2 were not defined as the time when relaxation is complete. Instead, T1 was defined as the time when about 63% of the original longitudinal magnetization is reached. T2 is the time when transversal magnetization decreased to 37% of the original value. These percentages are derived from mathematical equation, but we do not want to go into more detail here. However, we should mention that 1 over T1 is also called longitudinal relaxation rate, and 1 over T2 transversal relaxation rate. Previously, it was believed that measuring the relaxation times would give tissue characteristic results, and thus enable exact tissue typing. This, however, proved to be wrong, as there is quite an overlap of time ranges. What is a long, what is a short relaxation time, and which tissues have long or short relaxation times? When you go to your favorite bar, which is naturally crowded, as it's a popular place, and order a long drink, representing water, you have to wait quite a while to get your drink. T1 is long. When you finally have your long drink, it also takes you a long time to drink it. So, T2 is also long. And we want to remember, water, liquids have a long T1 and a long T2. As water has a long T1 and a long T2, it is easy to imagine that watery tissues, tissues with a high water content, can also have long relaxation times. Interestingly enough, pathological, diseased tissues often have a higher water content than the surrounding normal tissues. Now, look at this gentleman getting a hamburger. These normally contain much fat and will represent fat for us. The hamburger is fast food. You get it fast. Thus fat has a short T1. What about T2? It takes some time to eat fast food, fat. However, you normally spend more time with your long drink. So, fat has a shorter T2 than water.